This lesson, we are going to learn the derivatives of the exponential functions. So it is important to know that with the power rule, the exponent must be a constant and the base must be a variable. However, in the exponential function, the base must be a constant and the exponent must be a variable. Now, let's use first principle to derive the differentiation rule for exponential function. First, let's write down the first principle. Second, we're going to find out what's f of x plus h. So we know fx equals b to the exponent x. So f of x plus h will become b to the exponent x plus h. Now, let's substitute f of x plus h and fx into the first principle. And we know if there is addition in the exponent, that means there are two powers that are being multiplied. And as you can see, they have b to the exponent x in common, so we're going to common factor them. Using the property of limits, now I can write them as two different limits. For the first square bracket, b to the exponent x when h is approaching to 0. Since there's no h, so the first square bracket just becomes b to the exponent x. The second square bracket, this is what we are not sure of. So we are going to use the table on the right, try to figure out what's inside that square bracket. As we know, h is approaching to 0 means h is going to be a very small number. So I'm going to say h is going to be 10 to the power negative 9. And I'm going to write this fraction here, put it over here. So I'm going to find out what the value is at the different b value, the different base. So the first base I'm going to use, it's not going to be 1. Because if b equals to 1, that means the function will be 1 to the exponent x. And we know when the base is 1, it's actually a horizontal line. That's not exponential function anymore. So the first b value we're going to substitute in, it will be 2. So now let's put 2 into b and put on the calculator. Let's see what the calculator gives us. So when b equals to 2, the fraction will become 0.69314. And the next number I'm going to try is b equals to 3. And I see on the calculator is 1.09861. The reason that I put on the bottom of the table because I can see the fraction, 1 is below the 1. 0.69 is below the 1, and 1.09 is above the 1. That means there must be a value in between here. It's a 1. That means I'm trying to find out what the b value is will make this fraction to become a 1. So the next number I'm going to try will be in between 2 and 3. So I'm going to choose 2.5. And when I put 2.5 into the base b, the fraction will become 0.91629. And I will choose a point between 2.5 and 3. So right in the middle between 2.5 and 3 will be 2.75. So I put 2.75 in the calculator again, and I'm going to get 1.0116. And usually, mathematicians will continue to do this. Add and now divided by 2 to find the middle and find the y value. And then you add and now divided by 2 to find the middle and find another y value. But here we are not going to do that now because I can see the value here is 0.9. That's around 0.1 away from 1. And this is 1.01 already. That means it's very close to 1. So the next number I'm going to try will be 2.7. So when I put 2.7 on the calculator, I am going to get 0.99325. That means this is a very good guess. Let's take another guess now. So in between 2.7 and 2.75, I will choose 2.725. So let's try 2.725. And you are going to have 1.00246. So as you can see, it's getting very close to 1. So now we're going to try another special number. The number is 2.7182818828. Say, pretending we do this several times. Now we end up with that number now. And let's put on the calculator. See what do we get. So we know this is going to be a very special number because when the number becomes 2.7182818828, the fraction actually becomes a 1. So we call this number E. You will see the calculator give you a 1. And now let's figure out where all those numbers come from. So if you look at your calculators, you can see there's something called ln, long. So I want you to put this on the calculator. I want you to try ln 2. So if you try ln 2 on the calculator, you will actually see they are exactly the same. And this is actually ln 2.5. And this is actually ln 2.7. This is ln 2.725. This is ln 2.75. This is ln 3. So now we know that when the base is E, the fraction will become a 1. So we call them 1 equals ln E. This means given any base B, okay, the b to the power h minus 1 over h can be simplified with ln b as h is approaching to 0. So that's filling our equation now. So we say limit h is approaching to 0, b to the power h minus 1 divided by h will become ln b. So let's do a summary. Given fx equals to b to the power x, then our differentiation will be b to the power x ln b. However, when your base b becomes e, then I can write like this. Fx equals e to the power x, then our differentiation will become e to the power x ln e. However, we do know ln e, which is 1, so we can simplify this equation to e to the power x times by 1, which is e to the power x. This section, we're going to try to use the differentiation rules for exponential function, but for the function with the base e. So let's look at example 1. You have fx equals e to the power 3x. So our differentiation will be, copy down the function, don't change it, times by differentiation exponent, which is 3, times by ln of the base e. And then because we know ln e is 1, so I can simplify the function to be 3e to the exponent 3x. So the next one, you have a g function, and same thing again. Let's use exponential function rule. So g prime x will become, copy down the exponential function, don't change it, e to the exponent x squared minus x, times by differentiation of the exponent, which is on the top, will be 2x minus 1, times by ln of the base, which is ln e, but we know ln e is 1, so we're going to write 2x minus 1 e to the exponent x squared minus x. For the next one, we can see this is a product rule. So f prime will become u prime v plus u v prime. And that's define our u and v again. So our u is x squared, so u prime will be 2x. Our v will be e to the power x, then our v prime will become e to the power x. Differentiation exponent, which is a 1, so times by 1, then we don't need to write it. And times by ln of the base, ln e, which is also a 1. So we can simplify to e to the power x. And that's substitute in. So u prime will be 2x. V will be e to the power x, u, x squared, v prime, e to the power x. And that's two common factor. They have x in common, they have e to the power x in common, What's left on the first term? You have a 2 left. What's left on the second term? You have x. Therefore, that's your differentiation. For example number 4, not only we have to find f prime, but we also need to find what's f prime at -1, means what's the slope of tangent when x equals -1. So first, let's look at the function. There's a 3, but there's no variable beside it. That means that's a coefficient. So we just need to differentiate e to the power x squared. So f prime, coefficient, leave it, and differentiation with this, which is e to the power x squared, times by differentiation exponent, which is 2x, times by ln e, ln of the base. But ln e is 1, so technically we don't need to write this. Next, we substitute -1 into the x. And you are going to have 3e times by -2, which is -6e. That will be the slope of a tangent at x equals -1. The next function, example 5, I think will be a lot easier if we can change this into product rule. So first, I will do fx equals e to the power x times by x to the power -2. And let's use the product rule. We will get u prime, which is differentiation ex, which is ex, times by v, plus u times by differentiation of the second function, which is x to the power -2. So you bring down the exponent, which is -2, x to the exponent, -2 minus 1 will be -3. And next, that's common factor. What do they have in common? Then we will see they have x to the power -3 in common. They have e to the power x in common. And what's left? So you take this out. And take that one out will be 1. And this one will be out. Then you are going to have x minus 2. And let's substitute 2 in there. That will be 2 to the power -3 e squared 2 minus 2, which will become 1 over 8 e squared times by 0. So our slope of tangent will be 0. For example number 6, we have to find equation of the tangent to the curve at the point -1 and 1. In order to find equation of the tangent, the first thing we have to find will be the slope. So let's write the equation down first. So y equals x e to the power x plus e to the power x plus 1. And let's find the differentiation, y prime. The first terms actually need to use the product rule because there are two functions being multiplied together. So differentiation of x, which is 1, times by e to the power x, plus x times by differentiation of e to the power x, which is e to the power x. So this is u prime v plus u v prime. And what's our u and v? U is the x, v is e to the power x. And the purple one, differentiate e to the power x will be e to the power x again. And differentiation of 1 will be a 0. Next, let's simplify this. So we write down y prime equals e to the power x plus x e to the power x plus e to the power x. And that will become 2 e to the power x plus x e to the power x. Let's substitute x equals -1 in to find the slope of tangent, which is 2e -1 plus -1 times by e to the power -1, which means 2e to the power -1 minus e to the power -1, which is e to the power -1, which is 1 over e. That's our slope. Next, let's find the equation. So in order to find the equation in standard form, we could just use the slope formula. So n will be 1 over e equals y1 is 1, x1 will be -1. And let's do cross multiplication. You get x plus 1 equals to e, y minus 1. And expand it and move everything to one side. And this is going to be your standard form of the equation of the tangent. Example 7, we are finding equation of the tangent line again. However, this time, there is another condition. The line is parallel to the line 2y plus x equals 0. So since they're asking for equation of the tangent, that means we have to find the slope. That means we also need to find the slope of a tangent, which is y prime. So y equals negative e to the power x. Let's do the differentiation, y prime. So negative is the coefficient, so leave it. And differentiation e to the power x will still be e to the power x. And before we can move on, we have to find what will be the slope. Because it's parallel to the line 2y plus x equals 0. Let's rearrange the equation. Divided by 2 on both sides. You will see the slope is negative half. So I know if they are parallel, they need to have the same slope. So I'm going to substitute the slope into my equation here, which is negative 1 over 2. Multiply by negative 1 on both sides. And this time, we're looking for a variable that is in the exponent, so we have to take ln on both sides. So ln 1 over 2 equals ln e to the exponent x. So if you have a division inside the ln, that really means subtractions between the ln. So that means ln 1 minus ln 2 equals to x ln e. Bring down the exponents. And ln 1 is 0, so it will become negative ln 2 equals to x times by 1, which is x. So now we know x is negative ln 2. So we have the slope, we have the x, but in order to find the equation, I also need to find the y value. So we're going to substitute the x value, which is negative ln 2, into our function y equals negative e to the power x to find y. So y will be negative e negative ln 2. And let's bring the negative sign back into the exponent. So this is negative ln 2. Because the property of log, I can put this negative 1 back onto the exponent. And then you will see y equals negative e. Ln is actually log base e 2 to the exponent negative 1. So technically, you can remove the e, right? So those e and log base e, they will remove each other. So you are going to have y equals negative 2 to the power negative 1. So I know my y value will be negative 1 over 2. Now we have the x, we have the y, we have the slope. Then we can find the equation now. So m equals to y minus y1 over x minus x1. So our slope is negative 1 over 2 equals to y minus negative half over x minus negative ln 2. And let's put the negative sign into the denominator. So I become 1 over negative 2 equals to y plus half x plus ln 2. Let's do cross multiplication. You do x plus ln 2 equals negative 2 times by y plus 1 over 2. You get x plus ln 2 equals negative 2y minus 1. Bring everything to the left-hand side. So it becomes x plus 2y plus ln 2 plus 1 equals 0. And this is the equation of the tangent line. Question 8. We have another equation, but this time we are finding the line that is perpendicular to the line 4y plus x equals 0. So first thing, we find y prime, which is our slope. So y equals e to the power x plus x. So y prime would be e to the power x plus 1. In order to find the x value, we have to know the slope. So we know 4y plus x equals 0. That's given. Let's rearrange the equation to find the slope. So divided by 4 on both sides, you get slope is negative 1 over 4. But since we're finding the perpendicular line, so the perpendicular slope will be positive 4, which is the negative reciprocal. And then we put 4 into the slope to find the x. subtract 1 on both sides, take ln on both sides, and I can bring the x down, times by ln e, and we know ln e is 1, so x will become ln 3. So now we have the slope, we have the x, we just need to find y now. So we substitute x equals ln 3 into the function y equals e to the power x plus x. And we know ln in log base e. And this can kind of go away using the property of log and exponential rules. So we get y equals 3 plus ln 3. Last step, we have to find the equation. So m equals to y minus y1 over x minus x1, which is slope formula. Slope is 4, so I'm going to write down 4 over 1 equals to y minus 3 plus ln 3, x minus ln 3, cross multiply, expand, and that's move everything to one side of the equation. Simplify it and rearrange then. So 4x minus y minus 3 ln 3 plus 3 equals 0. And this is our equation of tangent.